So what is the topic for tonight? So what is life? I'll look around the room. It's not too hard to figure out that all have been alive for decades. So this is an easy question because we've all been experiencing it, right? I see people nodding their heads. Great. So tell me what life is.
I am life.
Out. Explain, sir.
I am.
Well, it involves there's a lot of characteristics. Teleonomy, ability to reproduce. There's a lot of things that could qualify something as living.
Ah,
Oh, biology. I'm
From a biological
I thought
perspective.
it's more philosophical.
well, Mark answered the question by answering a different question. Anybody else want to try?
Well, Jesus said he is life.
Okay. But that was Mark last couple of weeks. This is biology tonight. We'll get to all that, but sure, of course, absolutely.
Nation with challenges and plans.
Okay, but what is life? What is
Death.
well, where is it?
The spiritual
Okay.
force breathed into us by God.
Yes.
That sounds pretty good, but again, it's not in the realm of science. So that's what I'm asking about, because that's what I'm supposedly going to talk about, right? But of course, like any professor, I'm going to get you to talk about it. I'm just going to ask you questions.
Sure. See, don't be, God said it.
And you can even share a table with me if you're comfortable.
And you don't biologists disagree on what qualifies as life? Don't they have different lists of things that they identify life with?
Sort. I don't want to drag this out any longer, but indeed, trying to ask what is life is a challenge. The way that Mark answered was possibly the most productive way to attempt to answer the question. Typically, when you think about life, if you exclude the supernatural realm, so God, and then there's a fair amount of hand waving that can go on, but eventually we're pretty much pushed to thinking about living things that we know about, of course, ourselves being an easy example, and then saying, well, if it has this, if it does that, and so forth. Now, life includes everything from bacteria up through fungi and protozoa to plants and animals. So when you're dealing about what is life, you really have to take all that into account. However, frankly, it's a lot simpler to think about ourselves or maybe other animals, because that is the kind of example that is most familiar and, for the purposes this evening, probably most productive. So trying to make sure I work in the square so I don't fall. Just that be interesting, might be damaging. Okay, so let's see. Okay, there's your first attempt to read. Are some attributes of living things. How could we say that's living and that is I'm living, but the wall isn't? All right. Out to you.
Growth.
Okay. Growth, and then what was that?
Breathe,
Breathe.
respiration.
Okay, those are two different things. Gas exchange is how I'll do for breathe, and respiration has at least two different meanings. One is, and the other one is a certain aspect of biochemistry. So I'm going to call biochemistry as metabolism. That's less scary.
Perhaps citric acids.
I wasn't expecting to have to put that up on the board, and that's good because, well, once upon a time, my students all had the opportunity to learn it such that they had a test where they came in and I gave a blank piece of paper and said, okay, put it all down, all the intermediates, names of the enzymes. Of course, I could do it too, and now it's like, no. Okay.
Genes or.
Okay. Okay. Let's see.
Nucleic acid.
See, actually, switch sides. Switch sides. Don't mind me confusing you, but once I get growth up here, I'm gonna put genes. Because depending on what we're talking about, could be DNA or it could be RNA, or I'll leave it there. RNA. Like,
So, non-descriptions.
oh, you got your hand up, you got you just bought it. What did you buy?
Another attribute,
Yeah,
removal of waste.
okay. Let's see. And that would be excretion. And if you think about it, you can apply this to a bacterium, you can apply it to a plant. Good, good. Some more. There are lots more. Who else has not contributed? Sorry?
Carbon.
Carbon.
Based.
Oh, carbon based. Okay.
Organic stuff we know about.
Yeah, how about?
It's the only ones we know.
Organic molecules. There goes my handwriting. That's organic molecules, trust me. Yeah. Oh no, another hand scratching. I mean, I do it too. We all do it, right? You hear all this, you read all that stuff about, well, now with COVID and everything else, we're trying to relearn how to behave, and that means don't touch your face and stuff. Okay.
Mentioned
Somebody said
Reproduction.
reproduction. Okay.
Why not? Not a violent.
I don't know, he told me he kind of shut me up a minute ago.
This is all built on where you started this, right? So,
Yeah, well, I said teleonomy, which is, having a purpose or goal or something. That could be reproduction, could be
okay.
all kinds of other things. Life wants to move towards something.
Oh.
Yeah, I'm not,
Even on the,
I'm not,
microbial, you know,
yeah,
journal.
I'm not discounting or dismissing, but I'm not sure it fits the category is the problem.
Category of life or the category
Of approaching that question scientifically.
Okay, I just heard a scientist say it the other day, last Tuesday.
Yes, I can say lots of stuff, only some of which I would be proper.
This is why I said biologists may differ on what the attributes are, because this was a different biologist and he may differ.
Well, the place where it gets different is when you get down to the itty bitty stuff. Are viruses alive? Well, if you're a virologist, you'll say, yes, they are. And if you're not a virologist, you'll say, no, you're not. And then there are entities smaller than viruses. And there's some new entities that are even smaller than that. But we're getting ahead of ourselves. But see, this guy obviously knows all sorts of stuff. And he and I could do this together, just talking back and forth. But that'll leave the rest of the crowd out. And I want everybody involved here. Let's try this one last time before I put a bunch of stuff on the board. Somebody else.
Response to stimuli.
Okay. Ready for this one? Irritability. That's the word that's used. Irritability. Response to stimuli. Okay. That's the word that's used in the trade. You know, it's easy to figure, okay, you go up and poke a bear in the eye and that's going to irritate them. But this is more general. It applies to a lot of different, not violent necessarily, scenarios. Okay, now, notice that I put up two different sets. What are those two different sets?
Structure and function.
Structure and function, yeah, for anatomy and physiology. So here's structure, and here's function. Or anatomy and physiology.
So you could have a cell wall and membrane.
Ah. So how many of your patients have cell walls?
Very few. Some of the infectious disease processes. So.
My long pause here, this is just in-house now. Whether or not you consider a cell wall as part of the living thing or simply a product of the living thing, you'll round and round and round and round. And certainly with bacteria, it's awfully hard to separate out the bacterium from its cell wall. But so yes, but let's continue with some more structure and anatomy. What did somebody say a moment ago? Oh, mitochondria, but I heard cell. Okay, here's the deal. The cell is the unit of life. Everybody impressed? Sometimes I would do that to students when they were getting a little sleepy. Okay, here's the deal. When you look at living things, there clearly is a structural world. Living things do have a way of arranging, organizing matter. And right here, we'll just put cells in. Okay. What do you have if you have a bunch of cells of the same type organized together? And it's easy to think about animals and humans that way. Tissues. Okay. And then if you got tissues organized together, you got tissues, organ systems, and then call them, well, you get up to organism. Okay. Okay. What's smaller than a cell? And I heard mitochondria.
It's microns.
Mitochondria, nucleus. You get the idea. We can go on. So one way to answer the question, what is life, is, well, anything that's made of cells. Maybe that's not very exciting, but for the way that the language is used, it's appropriate, it's accurate. And you could also say, well, if you have enough organization of matter in order to perform these physiological functions that we typically associate with living things, then the answer of what are living things or what is life is a system that has the appropriate kind of organization to be able to support these processes. And again, anything smaller than a cell can't do that. There are parasites that don't have all of the bits and pieces and don't do all of this, but they're inside a host, whether it's in the cells or out in the interstitial fluid or whatever the deal might be. And so indeed, there are, like, whenever you try to pigeonhole anything, we humans love to pigeonhole stuff, right? Come up with a label, stick it in there, stick it in there. Now I can think. True enough, that's what we're doing. But there are situations, cases, instances where things don't fit so well. So rather than dwell on the things fit so well, although sometimes it's a good place to get a PhD if that's okay. Yeah, you do that in theology too. You find something that everybody's fighting about and go in there and go, well, I think I know what's going on, blah, 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 blah. It may or may not be right. Doesn't matter. He's a PhD and I just had to go. Okay. So what is life? Well, that is one way to approach the problem. Let me try another way. I'm just, I'm totally, this is stuff I've done with my students for years, but in a different kind of setting. So try this. Let's imagine you're a freshman and you come into Taylor University, which is where I taught for 31 years after being here for 3, where I learned a heck of a lot about the interaction of science and faith here. John Newton and Rich Gray and Barbara Hersey and I doing at that time was world and secular worldviews, the Christian secular worldviews, which now has been renamed a few times. The course is still out there giving that way of students to think. Anyway, so here you are, you're now a freshman. It's the start of the semester in the fall. You're just away from home. Some of you are cheering inside. Some of you are crying inside. Some of you are doing both. And now this professor comes in and says, tell me about your favorite pet. Okay, somebody. I'm now asking you, freshman. Favorite pet. I could say, tell me about favorite grandchild, but I'm not going to do that because you'll see why very quickly. Least favorite pet. Somebody give me something.
Anaconda snake.
You got an anaconda snake at home? Okay, forget it. You were going to say. Your dog, Chocolate. Okay, give me the 46-second explanation of your dog, Chocolate.
I agree. Kind of similar to a lab. He is a great hunter and was very helpful in fending off reptiles that wanted to invade our property.
Okay, and how about his personality?
Mostly business oriented, some fun loving bits of him, but mostly he just wants to.
Sort of like when you have a grandchild, I guess children, but none of us remember that, but grandchildren. When they're babies, that's when Ying loves them because they can't get away and she can snuggle them. And then they become bipedal and then they start to get sentient. And now they're around, and now they're so busy, they got so much to do that you can't stop them and they're just, being snuggled by Grammy is no longer of great interest. Okay. We're going to take your dog. This is a mind experiment. Well, what's the proper word?
Your Duncan experiment.
Yeah. What's the English? Is it?
Thought experiment.
Thought experiment. Thank you. All right. I got a bell jar up here, right here. Some of you probably don't know what that is, maybe you do, but it's a jar that's this seals down here, and it may or may not have a stopcock, meaning up here at the top, a way that you can plug up into it. So this one has that. You can close it and open it. Okay. And I've got over here a vacuum pump. That's vacuum pump. Okay. So
Just like it.
I have many talents. Your dog's name was Chocolate. Okay, Chocolate. Ooh, yum. Okay, no. Plop the bell jar down on top. Chocolate's in there. Remember, I did this with freshmen. Okay. Anyway, don't think about that too much. It's been 10 minutes. He's in there. It's getting all foggy in there, kind of wet dripping down, and he's not looking happy at all. Give it another 20 minutes, and he's just kind of slumped over, and you pick the bell jar up. Thump. Thump. Chocolate is dead. Oh, Chocolate was alive. Chocolate's dead. The life left Chocolate. We can isolate life. Okay. Chocolate, plunk, stopcock with tube going blah, 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 blah. And I've got a trap down here, not a trap for the stuff in your water line or whatever, but a trap for life, right? Blah, 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 blah. The life is leaving Chocolate and getting trapped down. Blah, blah, blah. Okay, turn it off. Undo this. Look at that. It's kind of shimmering. Okay, life is not a substance. Okay, that's just another way to help us to try to think about the question, the problem. So what is life is, I have other things I could do. That's enough. But you can see it's a difficult problem. It's like somebody asked you, oh, what is some word do you use all the time? You go, well, it's trying to write a definition, even though you use it all the time, can be a bit of a trick. Well, here we are. Okay. Now, if we're going to talk about the origin of life, we need to be able to define, okay, that's part of what we're doing here, is trying to figure out what we mean by the terms that we're using. Questions, comments, discussion. I'm ready to move on to the next part of this evening. You're going to tell us what? No, I'm not. Lloyd?
Did chocolate explode because its internal pressure is still there?
Doing what I did in front of the freshman was bad enough, okay? Without putting that piece of reality in. I mean, another thing that I did was drop chocolate into a blender, okay? Because that's what cell biologists do. They start with whatever it is, and you drop it in a blender, put the cap on, and go. No, you just don't go. Because then all the
Chocolate in a blender would be all right, but not your dog.
what's red and green and red and green? Frog in a blender. Okay. Hey, I'm a biologist. What can I tell you? I'm a cell biologist. I deal with little things. So it's in the blender. That's not going to work. Got to let go. Let the big chunks fall to the bottom. Again. Just think it's a frog, okay? And now we can try to isolate life from, well, it's kind of the same. Oh, what you could do though is if you're doing cell biology is you blend it for a while and then you put it in a centrifuge and spin it and you get different forces depending on the RPMs and the radius and all that good stuff. And so stuff will settle out in the centrifuge tube. The stuff under that, the items under that condition that settle most readily will go down to the bottom of the tube and so forth. You can separate out different parts of the cell and examine them, which I've done with students many times, but no frogs were harmed. Actually, I was so excited because the classic standard way to have students learn about mitochondrial function is to isolate mitochondria from rat liver, which means you gotta rat. And okay. Which was no fun. Plus then the lab smelled of rat all day long. And I found a procedure that starts with cauliflower. Excellent. And that's what I did once I discovered that, which I can't remember whether I discovered that here at Montreat or once I was a Taylor. Hey, plants are alive. They got mitochondria. So it just smelled like coleslaw, for the day, and that was fine. Okay, but on to something different, unless there is additional conversation. I ask, if you want them to talk, I'm talking.
Where's the spiritual domain in all this?
Well, we're getting to that,
That's what I thought.
or at least I'm explaining how we're not going to get to that.
He's got 2 lessons.
Well, we
You'll
get
get there.
Okay.
3. Third one.
The third is origin of humans, which is a little.
Well, part of that is me and part of that's Mark, with my understanding, and I'm ready for my part.
Yeah.
Yeah. Okay.
I'm just looking at what structure. After you do all the things you just did, the chocolate, all the stuff on the left is still true.
It's still.
Still true. All that stuff is still there.
Oh, yeah. Well, yes and no. You certainly don't have tissues. You probably, well, it depends on what you did, but you may not have whole cells. Oh, yeah. Yeah. Well, but of course, if you remember what Lloyd suggested, then maybe some of that stuff exploded out through the stopcock and down the tube anyway. But, okay. All right. Now I'm going to erase that. Yeah, now that I'm here, what else should I pick up? Okay. So take one pass around. Lloyd, It is one of the blocks. Maybe last week? Yeah, I think it was last week. He put up something that surprised me. I thought, wait a minute. So I dug through my, of which there are so many.
Yeah.
Which I discovered, if you look at the, you can see I got about a fourth of the way in. And I didn't get to page, what was it, 253? Oh, here we go, 263, okay. And you can't see this, I know, I'm not expecting to. Well, I think it might have been part of your first slide.
It was an early slide.
And I saw that. And, let's just keep the extras over there for now. I said, well, that looks familiar. It's a little different than what I'm aware of. This was published in '86. This was published in '78. And
It's a,
today's also pretty good. Whenever I open this, it opens up right to where I'm going. And of course, now that let's be right here. Oh, come on. All right.
That's what bookmarks are for.
Every time I open this book, there it was. Okay. There is something very similar. And Hummel must have seen this and said, well, it's just I looked in his book to see if he gave credit. I couldn't find it. And I tried to find in this book, which is How to Think About Evolution and Other, was it Bible or Science? Bible Science Controversies by Dwayne Thurman. And I couldn't find where he gave credit for anyone, so I don't know. I've always assumed that he invented this way of displaying these items, which we're going to do on the board. You got to start right there at the place. So what this is my little break from science to put some context in. Now, we've had this from Lloyd and from Mark, but what I'm going to show you up on the board, and you're going to do it right there in front of you. That way you have yours. And that way you're also paying attention. If I just either gave you the whole thing or put it up on a slide, you go, but I want you to actively interact by filling in your sheet. And the reason I gave you something there is just so it has some spatial organization. Otherwise, you'll have this big cluster of things in some corner, right? Whatever. Okay, so. Sound of music. Let's start at the very beginning. A very good place to start. Okay. I never thought about it. My brain needs some, Okay. Fine. And here we are. Now, that needs to be explained both for politically correct reasons and other reasons. That's supposed to be all of us, folks, but if I start putting in man and woman or humankind, it gets to be more letters, and this gets to be a mess. So I'm using basically the smallest words that work for my purposes. So here we are. And here is word. Now, word can mean scriptures, the Bible. It can mean Christ, the living word. And over here, it is the world. Now, that's what you got. Lots more to follow. The idea now that we're working on is how to organize a lot of different concepts, principles, and so forth in a way that I think is pretty easy to keep straight. And at least initially, down here, this means folks that accept Christ as Lord and Savior, those that understand, accept that the Bible is God's word, and so forth and so on. There are any number of labels that you could use, but you get the idea. Eventually, we'll back off a little bit further and say, okay, now let's let it stand for all humans. But for now, this is a way to help fellow believers think about the interaction of the worlds of faith and science. Okay. This is arrow. It starts up here and comes down to the word. Yes, I see those writing implements in action. Here's another arrow coming from God down to the world. Words are nearly the same, so that makes it fun. Those arrows represent the fact that the word and the world are presented by God. God created them. Or, this will help a bit, this can be special revelation. And this can be general revelation. So general, looks like that's general revelation is something that, frankly, all humans can experience if they're open to it. And I would think all humans have. That's what most of art is about. Is someone looks at the world around and says, wow, wow, they're on the wall. Wow. And that's as far as it goes. They acknowledge that within the physical realm that they live, there's something going on. It feels like there's something bigger, but they don't know who. Very different category. Okay. But we Christians can likewise experience general revelation. And you all may have your own examples of that. Not preaching, not the word directly, but something in God's created order that says, slap, oh yeah, I see God in this. And living up here where we do, it's kind of hard not to, right? Okay. And try colors. These have no meaning other than just different. Okay. Now we got a little, I have to write smaller, sorry. Now, for those of you that are just watching and not writing, I shall cast aspersions upon you. Because I'm going to expect for the next 2 times, you're going to bring this thing back, because I'll probably be referring to it, and you may want to be annotating according to whatever we're doing. Okay. Special revelation is of God from God. General revelation is of God from God. Definitionally, they got to be in agreement. Okay.
Let's not contradict himself.
Don't get me started. But of course. Okay, now, here we are, ladies and gentlemen, boys and girls, with short to those in here tonight. Arrow going up. To the word. Here we are. Remember, we're starting by this representing those of us that accept the Bible as God's word, et cetera, et cetera. If you will, those that have spiritual discernment, or if you will, those that have the indwelling Holy Spirit. Those may not be the same thing, but it's all in the neighborhood. Okay. And we're looking at the word as believers, trying to understand what God has to tell us. And so we have a human process that we call exegesis. And as we do that, it impacts us. Just think about that. The Almighty God, creator of the heavens and earth, has provided us with a way to try to get closer to him by providing his word and giving us the capacity to read it, think about it, seek to understand it. You can go on and on. I'm not going to do a sermon. I can't. Okay, now on this side. Here we are, believers, looking at the world, the physical order. In order to understand, you can put in here any number of just practical application reasons, and material science and medicine and engineering and on and on. Of course, the other major way that we humans interact with physical realms through the arts, which is, that covers a lot of territory, right? You all understand that. Okay, and of course, as we interact with the physical realm, that in turn impacts what we think about ourselves. Here up is God things. Here down, human activities. Now, granting the reality of the arts for the purposes of this helping us to think about the interaction of science and faith, we can just call this one science. Science is not what's in the textbook. That's the product. Science is the process. We already have some very thoughtful presentations that we're going to report about this. But in essence, science is this process of examining the physical world through a particular process that only permits physical explanations for physical phenomena. Okay. And it's another color. Seems too often as though those two seem to be at odds with each other. There's discord. What's the source of discord? Human processes. Got the best intended, most ethical, smartest, whatever people. We're still going to not quite get it all. We'll get close enough so that we're confident driving out of here tonight. The electricity is going to light the road up for us, and the brakes are going to do what they've been built to do, etc. But all of those understandings of the physical realm are limited, but we've come to accept that limited understanding because it goes far enough to allow us to do things in the physical realm and mostly not get hurt. At least once we're on maybe 24 or so. Okay, so discord.
Excuse me,
Yes, sir.
talking about discord, then I might think one way and someone else might think a different way about it. But within myself, I don't like the idea of discord.
Probably you guys never thought that Lloyd was sensitive. I just said probably you never thought about Lloyd being sensitive. Okay. Lloyd and I have known each other since '81, so I pick on him all the time. He picks on me all the time. That's why we ran away for 31. No.
But you came back when you could.
That is absolutely true. That is absolutely true. And the time at Taylor was wonderful. But I'm really glad that we're now almost 11 years back here, which has been marvelous.
Where is Taylor?
Oh, I'm sorry, Taylor University, which is in Upland, Indiana, which you all know is halfway between Hartford City and Gas City. North central Indiana, between Indianapolis and Fort Wayne, north of Muncie, Indiana, if that means anything, out in the cornfields.
What's it known?
You all know Taylor, Wheaton College, right, in Chicago. Amongst the world of Christian colleges, Wheaton is rightfully seen as the Harvard. Taylor, likewise, rightfully is if not Princeton, at least it's right there. Okay. And I was thrilled to be at an institution for all those years where the Word of God was held in high regard, and academics in whatever area was likewise held in high regard. And I got to be part of that process. And you got that little handout which you can doodle on, to work with my bio majors, which is to say among the best academic students we had at Taylor. who came from very conservative backgrounds, both theological and, let's say, social. And a lot of them were really uptight, especially being in the sciences, especially being in biology, because, well, biology, evolution, and all of that. And yet they felt, rightfully for any of them, that God had called them to be physicians. Therefore, they had to, science. But many of them were ill at ease. And so what I found myself doing, I taught the principle of cell bio to the freshmen. I taught cellular molecular biology to the juniors and seniors, molecular genetics, developmental biology, general biology a few times, nutrition a couple of times, but mostly that kind of stuff. And then I also did the biology capstone, which was great fun, which was a combination of biology and theology and history of science and history of, it was great fun. Oh, and I was strong-armed into doing bioethics, which I had no background in. But I did that as a once-a-week, 3-hour meeting in the evenings. And that was great fun. That was great fun. I learned a lot, and I think the students learned a lot. We're sitting around the table, maybe a dozen of us, of course, I gave them plenty of things to read, just like I'm going to give you some stuff to read. That's your responsibility for next week, but I get ahead of myself. Okay. Where were we? I lost my train.
I asked you what table it was all about.
Sure.
That was my question.
Yeah. And so, among other things, I had several, turns out to be women, students who were quite good and who were quite good at soccer and at volleyball. I grew up, you and I met at Ohio State. I've been in that scene, and I've solidly turned my back on all of that, whether it's collegiate or professional. But at Taylor University, where I knew the students, some of them, and they were good students and they were good athletes, we would go and cheer them on. It was great fun, especially after the volleyball games, when they would come and give us sweaty hugs. And here my students are, in class, I would, oh, you really are that tall, aren't you? Okay. So I am really glad that God took us there for that time period, because I really would like to think that a lot of students came in uptight about their faith and academics. And by the time they got done, their faith was stronger and they felt a great freedom being able to explore academically, whatever, not being fearful that somehow something's going to gobble God up. And that's part of where we're going right here. Getting there. But other comments, questions? Okay, now let me just check on that. My organization has broken down. Just so I don't forget. Let's see. Oh, sure. Okay. I'll go for some other color. Okay, over here on the side of exegesis, world special revelation. And we've heard this already. The kinds of questions that are accessible over on this side are things. I do the W, but I keep doing the J. They're not exactly the same. Who and why? And why, specifically intent. So teleology. Back to what Mark did teleonomy, which I didn't know. So anyway, but why in the sense of intent, meaning purpose. Who, over on this side, we tend to be dealing with questions that take the form of either how does something work, or just what is it out there? Is it a rock? Is it a turtle? Etc. These tend to deal again with, make it really simple, meaning. And personality, obviously. And these tend to do with mechanism. What? And I also learned in my students that oftentimes a why question is actually a how question. Why does the sun come up every morning? Well, the Egyptians had an answer for that, and other ancient philosophy systems had an answer for that. Nowadays, we talk about the motion of the heavenly bodies and the rotation of the earth specifically. Okay, so why, and it's more useful for the purposes of discrimination, why is meaning? It's teleology, the end of things. And how and what are less confusing. Science deals with how and what. Exegesis, coming to understand any piece of literature. Write it out. You're trying to understand, well, what's going on here? What's the meaning of this? And I trust eventually, one of the things that I found myself feeling shortchanged, maybe it was the night that I missed out on, was you never really did too much with authorial intent. But maybe I missed that on the second week, which is the one that I missed. But anyway, I know you were in the weeds on lots of stuff, and for you, just barely hitting the heads of the weeds up at the top. But okay, metaphors or similes or something. Okay, now, a few other things. Again, I did this twice a year, and I've done it for 15 years, so I need a cheat sheet. Let's see. Yep. Okay. Yep. Okay. Now, the phrase biblical theology, as Mark can tell us, has a very specific technical use, and I'm going to misuse it because I'm not even sure what biblical theology is, but one could say that over here, that's all worked out. That's not one of mine. Okay, well, let's see if it works. Biblical theology. And over here, we could say, now we're kind of mixing the territories up. We could say that over here we have natural theology. But I'm less happy with that because, anyway. But, okay, I just lost my train. Sorry, I've not done this in some time. Oh, sure, of course. Done. Worldviews. Naturalism and atheism. I always, with my students, try to avoid atheism. So, ooh, bad, atheism, without God. Where using theism implies a monotheistic personal God. Theism is not the God of, name any other, well, except maybe the other two books, what it is books, but okay. Over here then, looking at the world and trying to understand by way of the mechanism of science is an expression of naturalism. That is, naturalism, there is nothing but the physical realm. Now, clearly we don't ascribe to that philosophical naturalism because we acknowledge that there's more there than the physical realm. But, and I'm not sure which the right conjunction is, or the right color for that matter. What is it? Get this in. This, if we now broaden this to be any thinking person, sorry, I'm blocking you guys out. This little corner over here is all that philosophical naturalists have. Those that claim there's nothing but the physical realm. A denial of God, a denial of the supernatural, and so forth and so on. So when they're faced with any question, they have to go to the physical realm for their answer. They have either decided to deny or whatever the reason is. And that's why you have some people saying some kind of crazy, from our perspective, things. They don't have any other place to go but to answer who, why, meaning. They've got to put it in terms of physical processes, physical entities, and so forth, because they've committed themselves to a worldview of naturalism, of philosophical naturalism. Where are we as believers in all of this diagram? Are we down here? Where are we? Are we? We're not limited at all. We got the whole thing.
However, some don't. There are some who limit left side of all there is that's real.
That's a problem for them. They have no way to deal with anyway. I haven't met folks like that, but maybe there are. Anyway. As Christians, okay, back to Christians, we can do this. We can do this as naturalists. That is methodological naturalism, a phrase I heard someplace, but these last couple of nights, but I don't remember. That is, as Christians, we can do science just as fully and completely as anyone else. We'll do it, however, from the perspective of methodological naturalism. We will behave as though there is no supernatural realm, there is no God, because science doesn't do that. It only looks for physical explanations for physical phenomena. So here we are. But we have all the rest of this. Our well-intentioned, but sadly lacking in the whole story, philosophical naturalists, for them, there's nothing but the physical realm. They are limited to this. Notice, when you're faced with that kind of confrontation of, well, you Christians are so narrow-minded and so forth and so on, I'd like to think that now that you've seen this, or you were kind of aware of it already, the problem is you have to cover the smurf, okay? It's not for laugh at people like that, because you realize, no, you're the ones that have the narrow perspective. You're the ones that are missing the whole picture. Okay, comments, questions? Yeah.
Would that change if the definition of science was expanded somehow to include this?
Sure, but then it wouldn't be science either. I mean, I don't know. I'm sitting on sitting at the breakfast table, and I got my glass of orange juice, and I turn around, and it's empty. Oh, God must have drunk it. As opposed to your fast-moving granddaughter who knows that, yeah, et cetera, et cetera. And so there's a lot of folks will try to do that. Oh, okay, I'm going to step on some toes here, I bet, but I always find this amusing. Scientific creationism. That label alone, I think, is both hilarious and sad. I'm sorry, but what folks that pretend or claim that, do you hear what they're doing? They have greater faith in this human activity of science than they have in God's word. And so in order to support their particular interpretation of scripture, they call on the, what's the word I want? Import of the status. They call on the status of science to support their beliefs in God. As I said, it's funny, and then it's also very sad. So, indeed, what this, for me at least, really helps with is to set out what each territory of human activity is properly structured for and aimed at, and trying to blend the one with the other. And well, here's, Lloyd is going to give some talks in a couple of weeks with all different kinds of ways to try to do this, which is great. But I always get lost in the weeds, and this, for me, helps me to keep on track and not to get too lost and confused. Yeah.
Okay, you hear some Christians say, or it said, that true science is based on Bible. Now, I'm just wondering, people that say that have a kind of a different definition of science. That's what they say. True science is based on.
I could redefine hockey that you don't wear skates, you wear hiking boots, and that you don't use a stick, you use a broom, and you don't use a puck, you use a ball. What is that? Broom ball. It's not hockey.
So,
I just came up with that, by the way.
and that's brilliant, by the way. So Mark here specializes in the left-hand side.
But he knows a heck of a lot about the whole diagram, for sure.
Well, he does, but I think he depends upon people like you, trust people like you for the right-hand side, because that's not his expertise. And you trust people like him for the left-hand side.
And just to throw another piece of that into, when I arrived at Taylor, when I came from the postdoc in Boston down to here to Montreat, I knew nothing about integration of faith and learning. It wasn't something, I had been in the lab for 9 years or 10 or whatever, pounding away. And that really opened my eyes. Teaching, hey, I was learning in that course. So when I went up to Taylor, I took that learning that I had here and then built from there. But I also realized very early on that at Taylor, this phrase, integration of faith and learning, was really one of the centers of the educational process there. And learning as in the sciences, I think I've done that pretty well. But faith, I've had plenty of sermons, plenty of Sunday school, some small groups and all that, but it wasn't, that's not academic. And so I decided early on, like third or second year we were there, I needed to take some Bib Lit courses. So I started taking Bib Lit courses, biblical literature, Old Testament, New Testament, and then some of the books and so forth. And for some reason, I guess I must have realized that I was heading someplace with this, because I also decided as a 30, anybody remember being 35? Oh, wow. To take, last year, to take their freshman gym course. They called it Fitness for Life, because I think I knew that eventually I was going to have to fulfill degree requirements. So I better do it now rather than later. So here I am as maybe second year there, and I'm taking that course. And at the end of it, it was both classroom and physical activity. At the end of it was either a 2-mile or a 1.5-mile run, whatever. And I was annoyed that some of the students beat me. What can I tell you? But I kept taking courses, biblical literature courses, until I indeed had too many courses to be a part-time student. So I had to declare a major of biblical literature. Got one of my friends, colleagues, Bible professors to be my advisor. And it only took me 11 years to get my Bib Lit degree. Now, clearly, I have not the knowledge that Mark has, but at least I did what I could in the context to bring myself up to speed to some extent. I even took the 2 semesters of Hebrew, which was wonderful. When stuff is up in the news and it's from Ukraine or Russia, I'll try to, because I had Russian and I remember the sounds and some of but Hebrew, I don't remember anything except context. So the main thing I learned about Hebrew was context. So, yes, but.
All right, so you were a bad example. Me, I'm on the left, I'm on the right side, and I'm trusting him for the left.
I was starting to think maybe, Andy, you should have taught those first 2 weeks.
Well, who knows whether this is the one offering or whether it'll become a yearly thing, but what can I tell you? We're going to be in St. Martin those 7 weeks in January and February. But okay, back to the storyline though. Other questions about this guy, which I'm putting up there because I find it so useful for myself to keep my thinking unconfused. What can I tell you? I'm ready to move on to this, but you aren't, because you're going to keep those pages. You're going to think about them. You're going to bring them back next week because I'm going to refer to them again. But I'm ready. How are we doing here? Oh yeah, wonderful. That's 2/3, and it's exactly 2/3 of the time. Such a deal. If nobody asks questions, so we can get there. Oh, I didn't say that. Okay, I'm going to erase them. No, I'll leave it there. I intentionally would leave that there for the students. Yeah, actually, I had it done on the board in my office, so when they came to visit, they couldn't help but see it. Okay. It's actually, I'm going to have to erase it, some of it anyway. Now we're moving back to the Oh, I'm sorry. The advertised track. Just to say today is about what it's like. Well, we did that. I mean, as much as one can, especially in half an hour, we did that. Recall over on the anatomy side, genes were up there. It's going to be DNA, but I'm saving that for now. Okay, this next little bit is a way to get ready for next week. What is next week?
March 9th.
Origin of life.
Oh, it's time, changing the time.
Literalist. And I don't know. That way we have-
Spring
I
break.
created schedule, Phil.
It's spring break.
Yeah. Okay. That's where we're headed. Now. Sometimes if I don't miss on them, person out. And what that lays out is information flow. DNA, deoxyribonucleic acid, RNA, ribonucleic acid, and then protein. Okay. In living things, for the most part. And I should also, yeah, this is a 40-year-old, well, maybe a 20-year-old version of very, very basic biology. There are all kinds of, oh, this and then that. Oh, don't forget, yeah, we're not going to do any of those. Here's the deal. DNA, to be simple about it, is this molecule, linear molecule that has 4 bases, A, T, G, and C. Many of you already know this stuff. And that spells out genetic information. Now think about it. We've got an alphabet of 26 letters. The words are what? 3, 4, 5, 6, 7, 8. Beyond that, they're just kind of showing off, which I'd like to do. But here we've got an alphabet of 4 letters. But a really, really short word would be a couple of hundred of those long. And many of them are thousands, if not even longer. It's more complex. And that's how the information to make proteins is laid out. So think about DNA as being this lockbox of information. And in order to put it into a system where that can be used, RNA copies are made. So let's see this. If this is DNA, double helix, and I don't know, GCAT, somebody give me a letter. G. Another one,
T,
another one,
T.
another one. What do I see? Okay, there. There are hydrogen bonds. I'm not talking about all of that. I could, but the stereochemistry is such that where there's a G on one strand over here, there's going to be a C. Where there's a T, there's an A, there's an A, there's a T, and there's a G. You'll notice it runs in 2 directions, right? If we call that this way, arrow, and this way. But it's the same information. And so the way that information is replicated is DNA unzips, and you make 2 new strands, single strands, and now you've got 2 brand new double strands. In the case of RNA synthesis, the DNA unzips over short length. Make an RNA copy, same sequence, except that instead of C, you got U, but we'll worry about that. And now you have this copy of the genetic information for just part of the genome, which then gets shipped out to things called ribosomes, which are the factories that synthesize protein, where they take this information and that tells them which of the 20 or 21 amino acids goes in next. Okay, now some of you are going, yeah, and some of you are going, oh. Yeah, but je ne sais pas, I don't know, 2 different languages. Okay. There are stretches of DNA that contain information that do other things. We're not going to worry about that. But the reason I'm going into this right now is because as you read the papers that you'll be picking up, there they are. you're probably going to be a little bit overwhelmed. If you visited our home, as Lloyd has, first time he went up our driveway, he got out at the top and said, Andy, we're never coming here again. He's been back. Our driveway is a bit of an adventure. Well, these papers for next week are going to be a bit of an adventure, but what they are, they're two different, very recent overviews of how one could tackle the question of how do you move from inanimate matter to animate matter. Now, matter is not animate, but how is it that we can attempt to tell a story whereby once upon a time there was no life and then there was life, and that in between is moving from just small molecules to these longer molecules, information content, bunch of other stuff. So that's what you're going to see. Both papers kind of do a history. They end up in different places, but they do a different history. And the focus on both of them really has to do with this. That is, how is it possible to move from small molecules with essentially no information content to larger molecules, DNA, RNA, protein, which do have information content. And you'll see that there are two competing theories. They've been out there for decades now. They've all been, tweaked and reworked and so forth. It's still under it's under process. As we've learned and we'll learn again, the process of science is not the textbook. The process of science is a process. And anything you read is tentative in the sense that this might get tweaked or this may be totally revised. It depends. But mostly, as I said, with, I don't know, breaks or something, we've come to appreciate that we can function in this physical realm knowing that our understanding is incomplete. Okay, fine. So as you're reading these papers and underlining, that's why you really need a paper copy, and question marks, I know that probably all of us write in our Bibles, and I still find that to be troubling. It's like, who am I to, because that's God's word. I know. But be aggressive in your approach to these papers. Hang in there, push through, look for the big messages. Don't get caught up in the details, of which there are some. So that's my encouragement to you. Now I have one more thing to do, and that is what you'll find in those papers is how do we get out here in proteins in the sense that not all, but many proteins are enzymes. Which is to say biological catalysts. Catalyst. What's a catalyst that probably you have very close to you every day? Think of the exhaust system of the car.
Catalytic converter.
Yeah. What's a catalytic converter do?
That's my Chevy into a Cadillac.
It provides an environment. This is what catalysts do. Provides an environment in which the amount of energy it takes for a reaction to occur is lowered. That there's important. I could say it makes reactions go faster. That's true at the too simplistic, but that'll do. But it's not correct. It lowers the activation energy of thermodynamically favored reactions. But anyway, okay. So catalysts can be something like the surface of clay or the surface of a metal. And that in the catalytic converter is why people try to steal them. Why do they try to steal them? What metal? Yeah, it could be platinum or maybe palladium. It's one of that group. I can't remember now which one it is. There are two elements that are very similar. What does that have to do? Okay. Somebody mentioned the Krebs cycle a while ago, which is biochemistry. There are all kinds of, like thousands of different chemical reactions that could go on in our cells or in these spaces, the interstitial spaces between the cells. But the rate at which they go on is inadequate to support life processes. The way that living things manage to make their metabolism work is by very precisely and carefully providing the circumstances for just the reaction that needs to happen in order to, whatever it is, immune system responds, a whole bunch of stuff goes on, or you eat lunch or anything like that you can think of. It comes down to having the appropriate set of enzymes in that setting so that the reactions whereby you get rid of the pathogen or you digest lunch or whatever you might imagine go quickly enough that the job gets done. So as you read those papers, you will find a focus on, well, enzymes, because sometimes enzymes are already, anyway. I'm done with this, but I have one thing yet to do. And what I said, I mean, what I just said, you're kind of going, oh, yeah, I'm sure what, but how the heck does that happen? That's ridiculous. I quite agree. Get to the point where I did this with my college students, I would ask volunteers. And now this needs to be here, I think. Okay, which means these wires, I'm going to move that. Boy, I won't disconnect anything. Let's see. I was going to ask for volunteers from the crowd for the freshman was always entertaining. But Dan and Lindy Pierce are always willing to help with things. So they're coming up front. With the freshmen, it's always fun to pick the appropriate young lady, young man, because this gets a little bit close at times. But these guys are like each other, so that's fine. Okay, now, very often a chemical reaction. Is yours? Yours? Yep, there it is. Okay, who wants it first? Okay. So one piece of simple biochemistry is transferring a phosphate group from one molecule to another. That's how you regulate the activity of lots of enzymes and other things. Okay, so that's going to be a phosphate group, which is just a phosphorus with some oxygens around it stuck on some. Yeah, there's some hydrogens involved. Okay, there. And these two are molecules. They may be biggish molecules, but they're not. It's not something like water. Okay, not a little molecule, something bigger than that. Okay. Now, if these two bump into each other in the right orientation, there can be the transfer of the phosphate group from the one to the other. Now, notice we have this carpet. So now imagine, now we're on a billiard table, pool table, right? Here's the bumper here. And yeah, I guess I'll use this line here. The space is too small. Here's the bumper here. And I'm afraid I really need to make a little, I'm going to move this just a little bit. I need a little more room. So now they're typically move away from each other someplace inside this area. So the area with the lighter colored carpet. If you come over here, be sure to give this a good knock and see if you can knock something off the table. Or not really. Okay, and let's see. Okay, see how your hands are? Your hands are going to be there. And this gets on later, but no, you stay here. Okay, eventually, it won't take too long. I'm going to be the enzyme. I should have picked a couple that's different. And yep. Usually the ladies like here and think, yeah, but they're okay. Anyway, I have an active surface. I'm a protein molecule called an enzyme. And what I do is bind the molecules whose chemistry I'm going to catalyze, okay? So I have this binding site or active site. Here it is. And although it's hard to leave it, this is specific for something like that. And this is specific for Dan, like so. Which is to say, when they happen to bump into me in the right orientation, they'll stick. But right now, I'm not part of the process. You guys are billiard balls but don't go any faster than is safe. But when you come to the edge, you bounce off according to the angle, etc., and start. Just, you know, run. Yeah. This could take a long time, right, to get them to bump into each other just the right way. Plus, they would have to bump into each other with enough energy. That wasn't enough energy. Okay, how are we going to speed this up? Well, one possibility is to increase the concentration, so we need 25 Lindy's and 20, okay. But that would speed it up. Another way is to heat it up. Have them go faster, go fast. No, I don't want, no. There. I also picked you because I'm pretty sure you guys are pretty good on your feet, whereas I'm not anymore. Okay. But this now represents one of these chemical reactions that needs to go fast enough so that life can proceed. So now let's put the enzyme in place. And this enzyme, because he's old and tired, it's just going to stand here. And now you guys are going to bounce around some more. But eventually, one of you will bounce into me on the side. No, other way.
This is me, that's you.
So just randomly. Okay, ka-chunk. Okay, you're locked in place. And now. Okay. Now we have this induced conformation thing, which is that when the active site on the enzyme has the two substrates. Not yet. You're just so excited. This happens. Chunk. Imagine all the chatter going freshman, right? And under this circumstance, the energy to have that phosphate group pass from one to the other is enough. And now, because wait, that show them now here. Okay. Now these two molecules are different, and they're different. Their stereochemistry has changed, and so pop. And you come loose. So catalysis, that was very, very cartoonish, but I think it's at least pretty accurate for many enzymatically catalyzed reactions. That's how enzymes work, which is useful as you now read the papers for a week from now. Okay, we're done. Be sure to pick up one each on the way out.
And last week, the class gets out a few minutes early.
Well, looky there.